So the LeetCode problem we are going to solve now is called target sum, and we can see that this one is a LeetCode medium problem and also an extremely well-liked problem on LeetCode. We are basically given an integer array called nums, and we are also given an additional integer called target. Now we need to build an expression out of these given numbers such that by adding one of the plus and minus syllables before each of the integer in numbers and concatenating this expression to basically create this target value. So here is an example. Let's say that if we are given values 2 and 1, then we can add plus before this 2 and we can add a minus before this 1 and combine them to build an expression such that minus 2 plus 1, which is going to result in the value 1. So now we can basically create bunch of different expressions like this using plus and minus sign. Now we need to return the different expressions that we can build inside the given nums array, there where the total sum becomes the target, and we need to return every single possible combination that can have such values. So let's say if we are given an example like this, where we are given nums array that contains 5 elements and all the values are 1, and we are also given a target value that sums up to 3. Now in this case we can use plus and minus symbol to create bunch of different expressions that I have noted down over here, and we can see that all of these are unique operations that all sums up to value number 3. And in total we can define that there are exactly 5 different ways for us to generate value number 3 from using this given nums array and using plus and minus equation, and in the end we need to return 5 as the answer in this case. Now first let's try to understand the very preliminary brute force approach. The logic is quite straightforward, that for any particular given number of input, all we need to do is just test out every single possible plus and minus symbols and make the subset sum of every single possible permutations and combinations. Let's say in this case we are given target to be 3 and we are given these 4 values. So what we'll do is first we will use all the plus values and we will try to see that if we are able to reach target. If not, then we will try to go reverse and we will try to add one minus over here and then leave all of the values are plus. Then we will make these two as minus, then we will make these three as minus, then we will make all four as minus, and so on and so forth. We will keep on checking bunch of different permutations and combinations. Whenever we hit target value, we will mark that as an correct answer, and in the end we simply need to return that variable. This solution works, it gives the answer, but it is extremely inefficient, and you can understand why. Because we are testing every single potential permutation and combinations, and majority of time we are going to be not targeting value number 3, we will have some other answer, so we are not focused on that. So we'll have to do things smartly. So before we come to the optimal approach, let's make few things or few mathematical equations correctly. Let's say that we are currently given bunch of different values inside our nums array, right? Now we know that all of these values, they can have some any particular meaning. The thing is, we can add all of these values and we can mark these values, so sum of all the values inside a variable called sum. So let sum be the sum of a plus b plus c. Now we are also given for a fact that we need to create partition amongst these a, b and c in such a manner that there are two partitions. First partition is s1 and second partition is s2, and the difference of these two partition becomes the target value. So this is one equation we can make. Second equation is sum of s1 plus sum of s2 is actually going to be this sum value as well. So now we have two mathematical quadratic equations for two different variables, and we know the value of target, we know the value of sum. So it should make sense for us to get the quantifiable value for s1 and s2, and let's combine them. So if we do combination of these two plus this two, we can create a new equation where the values are, we did nothing special, we just did sum of these two values. Okay, now in this scenario, this s2 and s2 are going to cancel out each other, so we can say that 2 of s1 is going to be target plus sum. So we know that we need to find a partition such that the value s1 exists, and the value of s1 is going to be simple, that is going to be target plus sum divided by 2, and we have the value of s1. Now if we can identify s1, then we should be able to identify s2. So s2 would be basically all the remaining values, and we will just add minus sign before them. Now the thing is, lucky for us, we are not being asked to calculate that what are all the different expressions. We simply need to provide the number of different expressions. So for that, we actually don't need to calculate every single possible pairs. We simply need to know that what are different ways we can generate s1, and this would be true for s2 as well, and then we can simply return that as the answer. Okay, so now we have established all of these things. Now let's try to also consider some edge cases and some scenarios that for sure we can say that they are never going to make anything. So let's say that if we identify that sum of all the values are less than 0, in this case it would be impossible for us to generate the target value. So in this case we can simply return 0 as the answer. Same way, if we identify that the value of s1 is not modulo by 2, it's not possible to modulo by 2, then also we can return 0. Next thing is that in any scenario we identify that s1 value becomes negative, is a negative value, then also we cannot find subsequent s2 value, because in front of s2 we are putting all the negative values, so we can return 0 as well. These are going to be our edge cases, so we can get rid of them. Now let's come to the meat of the solution. The aim is that we are currently given a nums array that contains bunch of different values. Let's say a1, b1, c1, all of these are some integer values. Now we need to create the combination amongst these values such that the sum of them, so a plus b could become s1, or a plus c could become s1, so on and so forth. We are not focused on adding plus or minus and all of these things. We are only focused on finding a subset sum amongst the given values that sums up to that value. And this is the critical moment of the entire problem, to understand that why are we trying to find this one. Okay, now we know what we need. Let's see how we can achieve this, and how is actually going to be solved by the most beautiful concept in the entire computer science, and that is called dynamic programming. Now why dynamic programming is a good candidate in this case? Well, reason is quite straightforward. Let's say that we are currently only given just one value, 1, and we are given some arbitrary target value. So in that case we can simply say that whether this makes the target or not, does not make the target. Let's say the target is also 1, then we can say that there is exactly one way to generate target. We can clearly see. But if we are given values 1, 1 and 1, now in this case the number of ways we can generate target actually increases with the increment of every single value. Let's say next value is 2, let's say next value is 4, so on and so forth. Whenever new values gets added to the equation, the way for us to generate that particular target becomes increasingly more. On top of it, our s1 also changes. So what I'm suggesting is that instead of focusing that how many different ways we can generate s1, why don't we just generate the entire sequence that starting from 0 all the way up to s1, that how many different ways we are able to generate that particular element, and that we can calculate very easily using every single numbers that we are given. And we are going to keep into the consideration that how many different ways we were able to generate some previous element, and based on that we would add that value to our s1. So that's why this is a good candidate for dynamic programming. On top of it, let's see that how does dynamic programming is actually going to work. So we explained that we are going to create a dynamic programming array. We also know that how can we generate our s1. Basically the formula for s1 is the target plus total sum divided by 2, and we simply need to generate this value. Now for our dynamic programming, we are going to have an array that starts from 0 and goes all the way up to our s1. Now what is going to be the value of dp of 0? No, now notice that this 0 indicates that how many different ways can we generate value 0. And in this case we know that there is exactly one way we can generate value 0, and that is by not using any values inside our subset sum problem. So there is one way, and this is going to be our base case that we can use as like a stopping point. Now let's say for an example, I'm giving scenario. Let's say that the given number only contains value 3, and the target we are given, let's say that this target is also 3, right? Now we know for a fact that if this number is 3, then we can make two numbers plus 3, and we can also make minus 3, because we can use two signs plus and minus. So in that case, if this number is 3, does it make sense for us to check that how many different ways we can generate value 1 and 2? No, of course not. We cannot generate value 1 or 2 using this value 3. We can only generate value 3 and above values. So we are always going to be considering this value 3. So what is going to be our dynamic programming equation? Well, dynamic programming equation is quite straightforward. Let's say that if we are trying to find that what is going to be the dynamic programming of 3, because current the given number is 3, then this is going to be that how many number of different ways we are able to generate 3 plus the total number of difference between dynamic programming of 3 minus the current num value. So current 3 that we have, so basically 3 minus num, and this would be the formula that we are going to be using in order to populate our dynamic programming array. Let me explain the solution once again, that at any given moment dynamic programming of ith number is going to be depending on dynamic programming of ith, which already says that these are the different ways you can generate value number I plus dp of I minus the current num value that we are iterating over. Because remember, if we can generate 3, we can also generate 6, like if we are given one more 3, so on and so forth. So if we are at 6 location and we know that there are two different ways we are able to generate 3, then there is going to be 3 different ways we can generate 6. Basically that's the way how it works. Let's say assuming that original value of 6 was 1. Now coming back to our problem, let's try to populate our dp array for the given case. Let's say that current given values are 1 1 1 1 and 1. So in this case all of these values are 1, and the target value we are currently given is going to be 3. Now for this scenario we are going to be using our equation that dp of I is going to be dp of I plus dp of I minus num's value, and we need to calculate our s1. So s1 is going to be target plus sum. So in this case target is 3 and the sum is going to be 5. So let me just mark sum is equal to 5. So s1 is going to be 5 plus 3, 8 divided by 2. So s1 is going to be 4. So we are going to initialize our dynamic programming array that is going to be extending from value 0 all the way up to 4. So let's just mark this value. Okay, now let's start making our base case. So dynamic programming of value 0 is 1, so that is obvious. We can't do anything about it. Now let's start populating all of these values one by one. Now the current value we are dealing with is value number 1. Now notice that we are actually going to start traversing in the reverse order, not in this order. And why are we going in the reverse order is to make sure that whenever we calculate the results or the number of subset sum, we calculate that only once, not two times. Because let's say that if in this case currently all of these values are 0 0 0 0. Now if I apply this equation and if I start with this 1, so position 1 we are going to be starting with, then this value becomes 1, this value becomes, now this value would become 2. Why? Because we are doing the sum of this value with this value, and so on and so forth. So the value would keep on increasing and we would count the same value multiple times. So that's why we will start counting in the reverse, and we will come up until this particular number value that we have. So let's start with value number 4. Currently the value of value number 4 is 0, and currently so this value is going to be 0 and dp of I minus none. So 4 minus 1 is going to be 3. This is also 0. So we are not bothered to check or update this value number 4, because there are no ways we can generate value number 4 using just 1 1. Now next, once again we are at dp of 3. So for that, and we are considering this very first one so far. Now once again equation is going to be 0 plus dp of 3 minus dp of 2. So 0 plus this, so this value is also going to be 0, so this will remain 0. Same way dp of 2 will also remain 0, because this is 0 plus 0. But for dp of 1, dp of 1 is 0, but dp of 1 minus num is going to be 1. So this value becomes 1 at the end of this equation. And notice that what we have done so far is nothing but just saying that if we are only given an input array that contains value 1, then we can only generate value or target sum to be 1 one time. That's it. Now we are considering our scope and we are including the second one into the equation. Let's repeat the same operation. So dp of 4 is still going to remain 0, and same way dp of 3 is also going to remain 0 because of this equation. But for dp of 2, now this value would become 1 as well. Why? Because now we have one way to generate value number 2, that is by using 1 plus 1. And for dp of 1, this value will become 2. Why? Because remember that we are following this equation, so this is going to become 1 plus dp of I minus num is also going to be 0, and that value is also 1, so this value would become 2. Okay, after this, now we are considering this third one. So once again, the value of dp of 4 is going to remain 0, so let's just leave it as it is. But for this dp of 3, this value is going to become 1, so let's just mark this one as 1. Now dp of 2 is going to become current value of 1 plus 2, so this value is going to become 3, so let's just mark this as 3. And this value is going to become 2 plus 1, so this is also going to become 3, so let's just mark 3 as well. Now we are considering this one. So for this particular one, now once again we are starting from position number 4, and this value is actually going to become 1 because the previous value is 1. Now this value is going to become 1 plus 3, so because previous value is 4, so let's just mark this one. This value is going to become 6, so let's just mark this one. And this value is going to become 4, so let's just mark this one as well. Okay, cool. Now we are at the final one. So for the final one, we are going to be doing the sum of these two values. So this value would become 5, which means we are saying that if we have to generate 4 using these values, then we have 5 different ways to generate 4. Same way, this value is going to become 10. So let's just mark this as 10, and let's just mark this as 10 as well. And in this case, 1 would become 5, and this one is going to remain 1 as it is. And now we have reached to the end of all the nums, so basically we are simply going to return this value as it is. This is the whole solution. Now look how beautiful this looks. Basically this dynamic programming array tells us that if we are given the input numbers as 1 1 1 1 1, then if we are given the target value to be 4, then we can generate it in 5 different ways. If we are given target value or s1 value, not target value, s1 value to be 3, then we can generate it 10 different way, and so on and so forth. So we are calculating for all the possibilities, and I hope my solution made sense. Now let's understand the time and space complexity. Time complexity is going to be simply big O of n multiplied by big total number of s1, because we will have to do every single iteration this time for all the values that are currently present inside our given input nums. In terms of space complexity, because we are using an additional array, it is going to be big O of n, but that is a reasonable and acceptable solution. It's not that bad, and it's actually pretty good because we are using memoization to solve this problem. So now let's see the coding solution for this one. So first we are going to create a variable called sum, and then we are going to iterate over the given nums array to include the total sum of all the elements, and that we are going to populate inside our sum variable. Now we are checking that if it is possible to make partition, which means we are checking few edge cases and scenarios. That is, the first one is that if the sum of target plus sum becomes an odd number, then we can simply return 0. If that is not the case, then if the sum is actually total sum is actually less than the absolute value of target, in that case we can also return 0 as well. If that is not the case, we are going to define our s1, that is defined by target plus sum divided by 2, based on the explanation we had during our solution. Now we are checking that if the s1 is less than 0, then also we can return 0. This is to make sure that we are preventing negative array size. If that is not the case, then we are going to initialize our dynamic programming array, where we are initializing it with s plus 1 plus 1 value, and we are going to have our initial base case for our dp array, where dp of 0 is 1, because there is exactly one way to sum up to 0 by using no elements. Then we are going to iterate over every single nums that is currently present inside our nums array, and for each of the number we are actually starting from s1 and we are coming down all the way up to nums and we are reducing one value. So there is a loop inside the loop where we are simply following the equation where the value of dynamic programming of j is going to be the sum of dynamic programming of j plus j minus num. And we are coming in reverse order in the second loop is to make sure that we are not counting the same element twice. If we go from num to s1, then there is a very high likelihood that we are going to keep on counting the same element multiple times, and that would give us all kinds of weird results. So in the end we simply need to return dp of s1, and this should give us the total number of distinct ways we can sum up to that particular target element. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code beats almost 99.78% of all the other solutions, which is our solution is one of the most popular solution on the entire LeetCode, which is pretty awesome. And we are also extremely efficient in terms of space complexity as well. So once again, the solution for this code is present in our GitHub repository. Feel free to go ahead and check it out from there. Thank you.